Image classification. Image classification in artificial intelligence. AI intermediate level. Introduction. Images contain a large amount of visual information such as objects, shapes, colors, and textures. Humans can easily recognize objects in images. For example, people can quickly identify animals in photos, vehicles on the road, fruits in a grocery store, handwritten numbers. Teaching computers to recognize objects in images is an important problem in artificial intelligence. One of the most fundamental tasks in computer vision is image classification. Image classification allows machines to identify and label the main object present in an image. It is widely used in applications such as medical diagnosis, autonomous vehicles, security systems, product recognition, photo organization. Understanding image classification is essential for learning computer vision and deep learning systems. What is image classification? Image classification is a computer vision task where a machine learning model assigns a label to an image. In simple terms, image classification equals identifying what object is present in an image. Example concept. Image means AI model means predicted label. Example. Image of cat means cat. Image of car means car. Image of apple means apple. The AI system analyzes the visual features in the image and predicts the most likely category. Why image classification is important. Millions of images are generated every day from sources such as smartphones, social media, surveillance cameras, satellites, medical devices. Example concept. Large image datasets means AI classification means organized information. Image classification helps computers automatically analyze and categorize visual data. This enables faster processing of large image datasets. How image classification works. Image classification systems follow a series of steps. Image input, down-pointing arrow, pre-processing, down-pointing arrow, feature extraction, down-pointing arrow, model prediction, down-pointing arrow, class label output. Modern image classification systems use deep learning models, especially convolutional neural networks, CNNs. These models learn visual patterns directly from image data. Image representation. Computers store images as pixel values. Each image consists of a grid of pixels. Example concept. Image means pixel, grid means numerical matrix. For example, grayscale images contain one channel. Color images contain 3 channels. RGB. Example concept. Red channel, green channel, blue channel. These numerical values allow AI models to analyze images mathematically. Feature extraction. To classify images, the AI model must detect important visual patterns. Common visual features include edges, corners, shapes, textures, color patterns. Example concept. Image means feature detection means meaningful patterns. Traditional computer vision relied on manually designed features. Modern deep learning models automatically learn these features. Convolutional neural networks for image classification. Most modern image classification systems use convolutional neural networks, CNNs. CNNs extract features from images through multiple layers. Example concept. Image means convolution, layers means feature, maps means classification. CNN layers detect patterns such as layer 1 means edges, layer 2 means shapes, layer 3 means object parts, layer 4 means full object. This hierarchical learning helps CNNs recognize complex objects. Image classification model output. Image classification models usually output probabilities for each class. Example output. Cat 0.92, dog 0.05, rabbit 0.03. The model selects the class with the highest probability. Example concept. Highest probability means predicted label. Training an image classification model. Training an image classification model requires labeled datasets. Example workflow. Image dataset. Down pointing arrow. Label images. Down pointing arrow. Train neural network. Down pointing arrow. Model learns patterns. Down pointing arrow. Predict labels for new images. Large datasets such as ImageNet are often used to train image classification models. Example Python code. TensorFlow, Keras. Image classification can be implemented using TensorFlow and Keras. Example code. From TensorFlow, Keras, models import sequential. From TensorFlow, Keras, layers import Conva 2D. Max pooling 2D. Flatten. Dense. Model equals sequential. Conva 2D. 32. 3. 3. Activation equals ReLU. Max pooling 2D. 2. 2. Conva 2D. 64. 3. 3. Activation equals ReLU. Flatten. Dense. 128. Activation equals ReLU. Dense. 10. Activation equals softmax. This model extracts visual features and predicts image categories. Real-world applications. Image classification is widely used across industries. Healthcare. Detecting diseases from medical images. Autonomous vehicles. Recognizing traffic signs and road objects. Retail. Product recognition and inventory management. Social media. Automatically tagging photos. Agriculture. Detecting crop diseases from plant images. Advantages of image classification. Image classification offers many advantages. Advantages include automated image analysis, fast processing of large datasets, improved accuracy with deep learning, scalable AI systems. Example concept. Large image dataset means AI classification means organized results. Challenges of image classification. Despite its success, image classification still faces challenges. Challenges include variations in lighting, object occlusion, limited training data, high computational requirements. Example concept. Complex image means harder classification. Researchers continuously improve models to address these challenges. Concepts learned from image classification. Understanding image classification helps learners understand. Checkmark how AI models analyze visual data. Checkmark how convolutional neural networks extract features. Checkmark how images are represented in machine learning. Checkmark how classification systems are trained. Checkmark how computer vision applications are built. Image classification is one of the core tasks in computer vision and artificial intelligence. Simple definition. Image classification. A computer vision task where an AI model identifies and assigns a label to an image. Final summary. Image classification is a fundamental problem in computer vision. By analyzing pixel patterns and extracting visual features, machine learning models can recognize objects in images. Modern image classification systems use deep learning models such as convolutional neural networks to achieve high accuracy. These systems are widely used in industries including healthcare, transportation, retail, and security. Understanding image classification is essential for building AI systems that can interpret visual information